In this video, we will be solving the equation of a line. And so we have a question here that says the points 1, 4, 4, 10, 9, 20 lie in a straight line. So on the right here, we have a graph of the points that we've sketched. And so what we can do is we can start to label the points A, B, and C. So 1, 4 we will call A, 4, 10 we will call B, and 9, 20 we will call C. And so we are meant to solve this question algebraically and not graphically. So we could draw a scale diagram and then draw a line to prove that they are on the same line, but we're meant to solve it by finding the gradient of each line. So what we're going to do first is we're going to find the two lines that we wish to calculate the gradient for. So our first line will be AB. So 1, 4 to 4, 10. And our next line will be AC, which will be from A, which is 1, 4, to C, which is 9, 20. And so the reason we only have to calculate the gradient is because both lines share the point A. And they share the point A, we don't really need the y-intercept to show if they stay on the straight line or not. So we're going to calculate the gradient of AB first. And so what we're going to start off is we're going to write the equation of how to find the gradient for a line. So this is m is equal to y2 minus y1 over x2 minus x1. And so we can substitute our values into it. So if we take y2 and x2 as 4 and 10, and y1 and x1 as 1 and 4, we can substitute the values in, and we get 10 minus 4 over 4 minus 1. So this is equal to 6 over 3, which is equal to 2. And so this is the gradient of AB. Now, what we're going to do is we're going to find the gradient of AC. Once again, we're going to use our formula for our gradient. So m is equal to y2 minus y1 over x2 minus x1. And so we have our points A, which is 1, 4, and C, which is 9, 20. And we're going to label each value. So for A, we're going to have x1, y1, and for C, we're going to have x2 and y2. I'm going to substitute our values in. So we get 20 minus 4 over 9 minus 1, which is equal to 16 over 8. This is equal to 2. So the gradients for both lines are the same. They're both 2. And they both share the point A. So since they share the point A and the gradients are the same, we can say that all 3 points lie on a straight line. So now we have another question with the equation of a line. So a line has the equation y equals 2x plus 6. The line crosses the x-axis at the point A. The line crosses the y-axis at the point B. The point C has coordinates 1, 8. So for part A, we have find the coordinates of point A. For part B, we have find the coordinates of point B. And for part C, we have find the equation of the straight line passing through the points A and C. So on the right, we have a diagram that we have drawn. So we have our line y is equal to 2x plus 6, and we have the point where it meets the x-axis and the y-axis, and we've labeled them A and B. And we have point C as well, and the line between A and C. So to start off, we're going to find the coordinates of point A. So point A lies on the x-axis. So this means the y values on the x-axis are 0. So the y value for A is 0. So to find the x value for A, we're going to substitute it into the equation of the line that we have. So our y value is 0. So y is equal to 2x plus 6. And then we have at A, so 0, y is equal to 0. So 0 is equal to 2x plus 6. And we've rearranged, so we get minus 6 is equal to 2x. And so x is equal to minus 3. So this is just minus 6 divided by 2. So our x coordinate for A is minus 3. So here we have the coordinates of point A. Now we'll find the coordinates of point B. So point B lies on the y-axis. So all the x coordinates on the y-axis are 0. So for point B, we know that the x coordinate will be 0. Now we can substitute it into y equals 2x plus 6. So at B, x is equal to 0. So y is equal to 2 times 0 plus 6. So this is just y is equal to 6. And this is our y coordinates of B. So we have our coordinates of point B as 0, 6. Now we have part C, which is finding the equation of the straight line passing through points A and C. So what we're going to do first is we're going to find the gradient of the line AC. And we're going to do this by using the equation m is equal to y2 minus y1 over x2 minus x1. And so we have our point coordinates of A. So A is minus 3, 0, and C, which is given in the question as 1, 8. And we're going to label each value in our coordinate. So for A we have x1 and y1, and for C we have x2 and y2. So we substitute those values in. So we get 8 minus 0 over 1 minus 3. And this gives us 8 over 4. So this is equal to 2. So now we have our gradient of C. And now what we can do is we can use our gradient value and use it to find the y-intercept. So we have y minus y1 is equal to m times x minus x1. So this equation will help us to find the equation of our line. So we're going to take point C to substitute in, and we have our gradient as 2. So we have y minus 8 is equal to 2 times, which is our gradient, 2 times x minus 1. And so we expand our bracket, so we get y minus 8 is equal to 2x minus 2, as we've multiplied 2 into our brackets. Now we're going to rearrange for y, so we get y is equal to 2x minus 2 plus 8. So this leaves us with y is equal to 2x plus 6. So this is the equation of the straight line passing through AC. So in our sketch, it shows that it's not the same line as given in the question, but we have solved that it is. So don't worry if your sketch doesn't match what you have calculated. It's only there to give you a rough idea of what you're trying to do. As always, thank you for watching and make sure you subscribe so you don't miss out on any new content.